Hey guys, welcome to another episode of Coding Segments. Today we are going to be covering the topic of recursion. For many people this is a hard concept to grasp, and that's okay. It's a different way of thinking, but once you get it down it becomes easier to use. First we will talk about the concept of recursion itself, then we will plan and create a recursive method to calculate Fibonacci numbers, and lastly we'll talk about the drawbacks of recursion. Without further ado, let's get right into it. So what is recursion? Recursion is just a self-calling method. So we're going to create a rectangle here and call it the method. This method is going to be called the doubler. What does the doubler do? It just doubles the number. So if we pass in the value 1 to the doubler, it's going to do 1 plus 1, and it's going to return us 2. Well, that's good for doubling one number. But if I wanted the doubler to double twice, I could have the doubler just call itself. So let's put another doubler in the doubler. Oop, wrong shape. There we go. No, go away. There we go. So now let's create another doubler in the doubler. Boom, and text. Boom. So as you can see, we have created two doublers. So when I give this doubler 1, it's going to do 1 plus 1 and give us 2. And then it's going to call itself and say 2 plus 2 equals 4. The doubler called itself, and that's what recursion is. It's just a method that continuously keeps calling itself. Now let's create another doubler inside the doubler that's inside the doubler. So now we're going to make this guy. Name it again. And then this one's going to do 4 plus 4 equals 8. And we can keep going on and on and on for quite a while. So what is it doing? It's just taking in a value to itself, solves it, it gives it to its next part, and solves it, and gives it to itself again, and solves it. So it's just doing portion by portion by portion until it gets to the final most inner portion. So it needs to know when to stop. And then that's when we're going to talk about the Fibonacci sequence. So what is the Fibonacci sequence? Fibonacci sequence is a mathematical pattern that results in very interesting things that I'm not qualified to talk about so much, but I can program it. So Fibonacci sequence starts with 1 plus 1, and that gives us 2. And after 1 plus 1, it does 1 plus 2, and that gives us 3. And then it does 2 plus 3, and that gives us 5. 3 plus 5, that's not typing. There we go, 3. 3 plus 5 equals 8. And I'm hoping you're starting to see the pattern here. If not, it's okay. We'll explain it. And we get 5 plus 8 equals 13. So what is it doing here? So let's get our circles out. And we'll look at this. So it's doing 1. That's not a nice place. There we go. 1 plus 1. And that's giving us 2, right? And that's fine. Lastly, 2. And we'll make that one magenta. Alright. So we got 1 plus 1 equals 2. And then we shift everything over. Now we got 1. Where did this 1 come from? Well, if you see, it's the same one as this one. And then we get 2. Let's make that a little bit bigger. 2, and make that magenta again. See, that's where that 2 came from. And then 3 is a whole new resultant. And we'll make him yellow. Or an orange. There we go, orange. Okay, and then we go back down to here, and we get 2 plus 2. That's the same 2 from above. Let's move it over a little bit. There we go. We get 2 plus 3. Where that 3 come from? Well, it's the orange one from above. It's a little more yellowish. There we go. And then we get a new one called 5, and we'll make 5 cyan. And then once again, 3, which was our orange one. More yellow. There we go. Blue, or 5, sorry, 5 being our cyan. And then we got 8. Purple. And then last row, And this sequence goes on forever to wherever we stop. And I wanted to know 1, 2, 3, 4, the fifth Fibonacci number in this case. And then 8 and 13. So we found that 13 was our golden number. Let's give it, cream? We stopped at 13. So I told the computer to calculate the fifth Fibonacci number. Well, that's fine and dandy. We can do it on paper. How do we program this? Well, first we need to identify the important numbers that are happening and patterns that are happening. So we see that 2 numbers are always needed. And then we can mark that as column 1. Let's see, can we type it in here? No, we'll just say 1. And let's not make it that color. Let's just stick to blue. So column 1, okay, and then column 2, and column 3. Oh, I don't like that positioning. Column 3. And we'll just mark up here columns. That's not how you spell that. Columns. Okay, cool. So column 1 is added to column 2 and reproduced in column 3. And the answer of column 3 is then moved to column 2. Also, the answer in column 2 is moved to column 1. That's why we start to see this diagonal pattern going on here. So if we draw a little diagonal pattern, we'll make it that color. So we can see that's going zoop, 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 and then it stopped here, of course. That's getting messy, so we'll get rid of those lines. But we see that everything just shifts over one space. So we're going from 3 to 1, or 3 to 2, 2 to 1, and going forward. So we know all the needed information in order to solve this is just 2 numbers. So we need 3 to equal 2, but we also need 2 to equal 1. Let's see, there we go. Now, order or setting does matter, but it won't matter so much once we start programming it. Once we've identified the key factors, so we know that we need to know 3 and 2, these 2 numbers are key. And we've identified the crucial parts in order to solve things. So knowing that, we can start programming. So, let's bring up our IDE. So let's create a new method called Fibonacci. I'm going to call it Fibo because I don't like spelling Fibonacci. Fibo. And what did we say we needed to know? I already said that we needed 2 numbers, so we know those are going to be ints, int num1 and int num2. But we also need to know when to stop. How did I know to stop at 13? How did I know this was the endpoint? Well, as I said at the start, well, I kind of said, I wanted the 5th number, right? So this was 1, 2, 3, 4, and 5. So I need to keep track of when to terminate. So I kind of have like a countdown. So rather 5, 4, or 1, 2, 3, 4, 5, let's just go 5, 4, 3, 2, 1. 2 and 1. So we're going, saying we're 5 away, okay. Now I'm 4 numbers away, okay. I'm 3 numbers away, okay. I'm 2 numbers away, okay. I'm 1 number away, there you go. So we just need to make a countdown instead. So we need to have a 3rd number to keep track of where we are. And we'll just call that count. Alrighty. We didn't say what the return type was. The return type is int. And it's mad at us because we have no return yet. Right? Yep. So to fix that for now, we'll just say return null. Even though that's not what we want to say, but you'll see it's happy. Cool. Well, kind of happy. Okay. So what did we say? So we need a return if our count equals 0. Right? Yeah. If our count is the same as 0, we just want to return the highest number. And we're going to say the highest number is stored in num1. Okay, so if we want, that will give us a value. Else, we want to return the next iteration. So we're going to return Fibo num. So we want num1 to get bigger, and num1 we said equals the result of num2 and num1. So num1 plus num2. Okay, and then we want num2 to equal num1, right? Num2, so now we're going to pass num1 as num2, and then we're going to decrement our counter by 1. Cool. That's actually should be all we need. Let's test it out real quick. For ease of use, I'm going to make a quick helper method. So a helper method is just a simplified version for the programmer to pass in items. So we're just going to ask for the count instead. That way I don't have to say 1, 1 every time. So Fibo, because Fibonacci sequence always starts at 1 plus 1. There we go. Actually, we need to return that. Why is it still angry? Cool, it's not angry anymore. Okay, now let's test it. We want to print out the 5th number, right? Because we already figured out the 5th number should be 13. So let's make sure we made the right thing. Print line, Fibo, and then we said 5. So we want the 5th one. Okay, it's still angry. Why are you angry? Oh, it's not static. Okay, make that static. And then you're angry because that's not static, right? Yeah, okay. There we go. Everything's happy. And let's see if it prints out 13 in our console line. That is not the right thing. That's last episode. We want to just close that out. Now run this. Oh, it got angry. Wow, very angry. Okay. Why did it do that? At recursion. Huh. Then the fun part, debugging. So, this doesn't really help us. This right here. So it broke here. Why is it breaking on line 22? It's not decrementing properly? Do we need to do it like this? If that fixes it. Yeah, I fixed it. Okay, so that was angry because order of operations, it was doing count, and then after it was done, it's going to do -1. When we wanted it to do -1 first, that's when we put the minus in front. And now that we see that that's working fine and dandy, we got 13 as we expected. So that's promising. And then we'll just try out the other numbers because should get us 8, I believe that what it was. Let's see, run it. We got 8 and that's what we expected, right? 8, cool. So we see that we only needed 2 bits of number in order to count it. We needed to know the, whoops, let's go back here. We needed to know the number preceding it and the summation, and that was adding through and going through. So we just needed to set 3 equal to 2, which we knew 3 was 1 plus 2. That's what we did here. 3 equals 1 plus 2. And then we needed 2 to equal 1, which we set there because it's passing into that parameter here. And we needed to decrement the count by 1. And we had to do the decrementation first. Originally it was not decrementing till all of it was done. That's why we saw a lot of errors going out. And then it stops here because count is 0 and we know the biggest number is here, so it stops at 1, which was our exit condition here. It's actually exiting down here, but remember this is where 13 living is in this state here at 0. Alrighty, that's great. Now let's talk about the bad things about recursion. Obviously, we already saw one issue. It's kind of confusing to understand. It's hard to debug. I'm surprised I figured it out as fast as I did. There was no editing there. That was live on the spot thinking. For a novice or even people in industry, that's a rough thing to figure out. So I'm glad that it came out okay. I don't do these coding things prior. I like to create the mistakes and hopefully solve them. Another issue is let's create a big number. So we're just going to go to 100. We're going to put another print statement here so we know when it starts. Print line, starting, we need the quotes, starting, calculations, and let's see what happens. Okay, pretty big, pretty fast. All right. And then if we make it to a larger number, what is that? 100,000? Yeah. We got an error, an overflow error probably. Yep, stack overflow error. So what does that mean? Stack overflow is, well, if we go back to our picture over here, we can scroll up and it's essentially how the box is going in the box, going in the box, going in the box, so on, so on, so on, so on, so much that at every given moment, it cannot forget this, or this, or this. And that's going into memory over and over and over again. So much memory that it just can't handle itself. It can't have that much thinking at once. And that's why recursion falls apart. Yeah. So how do we solve this with recursion? Well, the thing is, every recursive method can be done without recursion. And it probably should, especially in higher level languages. Higher level languages have a stack heap, a space, memory, just limited amount of things to stop it from computing your computer. This actually solved to 100,000. It could take quite a bit of memory. Probably not horrible amount, but more than the computer wants to let you have. Also in higher level languages, recursion's pretty slow. Slower than most things that you're going to be doing. Lower level languages from like the 70s and 80s can do recursion a lot faster than higher level languages that we're using now. And it's just generally a dead thing. It's a neat gimmick. You're not going to use it all too often. It's a very niche thing, and if you can get away from using the recursion, then I would recommend it. It's cool, it's neat, but I don't see fair use. Now in academics and stuff like that, they'll ask you to do stuff like this, and you're just gonna have to suck it up. Sorry, it's a cool concept, but in practice, try not doing it, because the only time it is good is when I don't have to store in every single value into some table or some large set. But those are whole different problems, and typically the answer is not recursion. So that's going to conclude today's video of recursion. I hope you learned a few things about it, understand the concept, see the pros, see the cons, and hopefully kind of get a sense of implementation. The key idea of this video was to make sure you understood the concept. Maybe I'll try and make another practice video of recursion at a later date. Enjoy the rest of your day.